Okay, so we'd like to resume. We'd like to continue. So still on selection bias. Example, in case control studies. So we have come back to give some examples of selection bias. So in case control study, some investigators may identify cases based upon previous exposure. Suppose a new outbreak is related to a particular exposure. For example, a particular pain reliever or painkiller like paracetamol or ibuprofen. If a press release encourages people taking this pain reliever to report to clinic to be checked to determine if they are a case, and these people then become the cases for the study, a bias has been created in sample selection. Why? Because you cannot just pick these people to become cases straight away. You take them, and because they are taking the drug, they are cases. What about if they took the drug and they didn't have the outbreak? They took the drug but didn't have any effect on them. Then why do you classify them as cases? What about the controls? There may be some people who did not take the drug but still had the disease outbreak or still had the outbreak, which can be as a result of another underlying condition or another exogenous factor which is causing the disease, but not the drug in question. So there is a bias. You taking the drug means that you have the disease or the condition. What about those who did not take the drug and still have the disease or condition? Or what about those who took the drug and didn't get the condition? So it's a bias. So bias has been created over here. Only those taking the medication were assessed for the problem. So, and leaving out those who didn't take the medication. So ascertaining a case based upon previous exposure creates a bias that cannot be removed once the sample is selected. Okay, so still on selection bias, let's look at attrition or cohort studies. In a cohort study, like I said, concerning the Boko crisis, people who share a similar characteristics may be lost to follow up. For example, people who are mobile are more likely, people who travel a lot, are more likely to change their residence and be lost to follow up. So if the length of residence is related to the exposure, that you studying long will cause you to be exposed to the outcome of the research, then our sample is biased towards subjects with less exposure, because the person was just staying in the community and the study was a 6 months, it's a 6 month study. So for instance, if you have a 6 month study, you have this is a study. So study period. So the study period was this. The study period was 6 months. So by 6 months the study ends. So this is 6 months. So if it is 6 months, we know that you have really been exposed to the risk factor. So number of months: 1, 2, 3, 4, 5, 6. This is exposure status. Exposure status. Okay, so if this person dropped out, this person also dropped out, that is lost to follow up. follow up. LF, loss to follow up. This one also loss to follow up. This one the 1.5 months. So this one is 1.5 months. This one dropped out on 2 months. Okay, 2 months. So we cannot say that in this study, if we say that those who drop up early, like exposure status is based on the risk factors, they being exposed to the risk factors based on how long you stay in the study. Then these people who stay 2 months and 1.5 months must be excluded from the study. They shouldn't be added to the study. It is only these two that are supposed to be considered because they stayed for 6 months. But if we don't do that and we still use information for this one who was part of the study only for 2 months and this one who was part of the study only for 1.5 months, if you use them plus these who were in the study for 6 months, then bias has been created because the exposure status for this one is different from exposure status for these ones. Also, in the cross-sectional studies, the sample may have been non-representative of the general population. This leads to bias. For example, suppose the study population includes multiple racial groups, but members of one race participate less frequently in the type of study. So another study, for cross-sectional study, we have what? Multiple racial groups. So we have Italians or Afghans. Italians being 500. Indians being 500 in a cross-sectional study. You remember cross-sectional study. Then Moroccans, which are Africans, being, because of racism, because they are Africans, they say, oh, let's take 200. Then Americans also being 500. If we do this, we have been biased towards the Moroccans, who are Africans. We pick only 200, but the rest we pick 500. Bias are set in. So example, in cross-sectional studies. In a cross-sectional study, the sample may have been non-representative of the general population. This leads to bias. For example, suppose the study population includes multiple racial groups, but members of one race participate less frequently in the type of study. A bias result. So the Moroccans are small. So you are going to compare them with the Italians, Americans, and the Indians. So you say that bias has been created. So let's define this. Information bias. Information bias arises as a result of inaccurate calibration of instruments, creating systematic error. Misdiagnosis. If the doctors or the nurses working on the team misdiagnose, or if a diagnostic test is consistently inaccurate, the information bias will occur. Recall bias, or remembering. You are not able to remember what happened in the past, what you were exposed to. If individuals can't remember exposures accurately, then information bias will occur. Missing data. If certain individuals consistently have missing data, the information bias will occur. Social desirability response. If study participants consistently give the answer that the investigator wants to hear, the information bias will occur because, you see, because of stigma, the participants are afraid that if they say this, if they say they have this condition, it will come to the public domain and everybody will know because they are part of the study, even though they didn't use their name. But they are afraid that their information will come out and they will say they have this sickness or this thing. So they will give you information that the society desires or likes. Oh, do you have HIV? Oh no, I don't have. I don't have. While she has. You understand? So because if she says she has HIV, even the husband will leave her. She can't even cook for her own children. That is. So they tend to hoard the information. That becomes what? Information bias. And the missing data bias also has to do with you not being able to collect all the data on a participant. You are not able to collect all the data on a particular participant, then it becomes missing data bias. So let's look at the differences between misclassification and differential and non-differential. So differential misclassification, that the probability of misclassification varies for the different study groups. Misclassification is conditional upon exposure or disease status. So if you interview cases in person for a long period of time to extract information from them, while the controls are interviewed over the phone for a shorter period of time using standard questions, we are most likely to misclassify cases than controls. And this can lead to a differential misclassification of exposure status between controls and cases. This is what this one means. You are having cases. For the cases, you interview them in person. But for the controls, you have to also, whatever you do to the cases, you have to do the same to the controls. But here in the controls, instead of you interview them in person, you use telephone call to interview them. And you say you are doing research. Whatever you do to the cases, do the same to your controls. But because you didn't do that, this is a differential misclassification of the exposure status. And when we say non-differential misclassification, that the probability of misclassification does not vary for the different study groups. It is not conditional upon exposure or disease status, but appears random. This is a random error. Using the above example, like the above example, this example. So with the example, if half the subjects, that's the cases and controls, for example, if the cases were about 50 and controls were, if the cases were 100, controls were 100, but you were able to interview 50 controls and 50 cases, then, and you did them at random, then we can say that you have done a misclassification bias, which is not differential. Meaning that whatever you do to the cases, you did to the controls. But instead of doing for all the 100 cases and 100 controls, you interviewed only 50 cases and only 50 controls. Meaning that when you increase the sample size, you'll be able to eliminate this bias. You did a bias to only half of the cases and half of the controls. Equal to cases, equal to controls. So if you increase the sample size, you eliminate that bias. But you are not supposed to do that. You are supposed to interview all the cases, that's 100, and interview all the controls, that's 100. But because you interview half of the cases and half of the controls, it biases the results. And this kind of bias is called misclassification or non-differential bias. So either type of misclassification or bias can produce misleading results. Thank you very much.